Thanks, everyone. I'm Miles. For those who don't know, I'm one of the original founders of JuMP. Um, I don't do much of the day-to-day work anymore, but I am happy to talk about what other people do. I work at Hudson River Trading, and just to clarify, I'm presenting in a personal capacity today. So this is my usual introduction spiel, but there may be people who haven't seen it, or for the benefit of people who watch on YouTube. What is JuMP? I'd say JuMP is part of the zoo of algebraic modeling languages. It allows you to write down a mathematical formulation for an optimization problem. It translates that problem into a format that um, you can provide to very powerful uh, pieces of software called solvers. Solves the problem, gives you the answer back. And there are many, many other software packages that do something similar to JuMP. AIMS, Ample, CVX, CVXPy, GAMS, Lingo, Minizinc, Pymo. It's like there's a lot of software packages that do something comparable to what JuMP does. So to give you a concrete example, this would be the JuMP code to formulate a constrained linear regression problem. What you do is you declare some decision variables x. You formulate some problem where you say a times x minus b, let's say, equals these residuals. You minimize the sum of the residuals. You put some constraints, whatever you want, on the variables. You say optimize. And then what JuMP does is it takes this algebraic representation and the data you provided, does some manipulation, passes it to, in this case, a software package called IPOpt. IPOpt does the hard work of solving the problem, and JuMP takes the answer and presents it back to you in a convenient format. Okay, so what makes JuMP interesting among all the other packages that do kind of similar things? I'd say JuMP has a nice syntax thanks to being embedded in Julia. We get to use the macro syntax, which is that @ sign. It lets you write things that look more mathematical than just pure code. We put a lot of work into the documentation. Our documentation is pretty comprehensive at this point. If you look at the PDF, it's hundreds of pages. It probably could be a book on its own. 1,500 pages. So quite comprehensive. The community is a big point of JuMP. Kind of the JuMP-dev workshop is one of the highlights of the JuMP community, but the community also happens on the forums. A lot of discussions during the year. A lot of discussions on GitHub, and I'm happy to be part of this and to see what people do with JuMP. JuMP is open source, so you can use it and modify it and apply it however you like, as long as you follow the pretty loose terms of the open source license. It is solver independent. Right now we support over 50 solvers, which means that you've written your mathematical problem. You can switch out the software package that we're actually calling on the back end, which is very useful if you're doing some research and you want to compare how one solver performs with respect to another one, or maybe you've got a weird answer and you want to see, did the other solver give the weird answer? It's very useful for those types of comparisons. It's embedded in Julia, which means that you can use a fully fledged programming language to do all the things that you want to do in addition to just solving one mathematical optimization problem. You can put it inside of a loop. You can put it on a web server. You can process data, post-process the answer, and it's all in one fully functional and efficient programming language. Sorry, by fully functional, I don't mean a functional programming language. It has a lot of functionality. JuMP supports interacting with solvers while they're running. This is a rather advanced feature, but it comes up surprisingly often industrial and more developed applications, what could happen is that um, there may be some implicit way that you specify the description of the optimization problem, where you have an exponential number of constraints and you only want to validate them in a lazy manner. That's one example. Or there may be ways that you hook into the solver and kind of help it solve. And JuMP, we've tried to expose everything that a solver allows you to do. We try to allow you to do that from JuMP, even though we've imposed an abstraction layer on top of that. It has a low overhead for model generation. It's extensible to new solvers and extensible to new problem classes. So we'll see during the talks that a lot of, we'll see examples of this during the talks today and tomorrow. I won't go through the other 20, 30 modeling software packages and give you a checklist of what does what, but I think if you've had some experience with other modeling packages, you'll know which of these points apply to those and which don't. Okay, so I'm here to discuss the state of JuMP, so I want to give you like a cartoon. 2 years ago at the 2023 JuMP-dev workshop, I presented this cartoon as my interpretation of JuMP's development cycle. So what happened, if you look at the timeline of JuMP, JuMP was released more than 10 years ago. It got a lot of initial interest. We won some awards. We got some users, and users started asking for new features, and we very eagerly said yes to a lot of things, and we got people excited, and then realized that we did not add all these new features in a way that was sustainable, and actually the feature requests kept coming in, and we figured out, oh, we cannot do what you're asking us to do because of some previous decision we made, and we decided to rewrite everything. That decision happened at the 2017 JuMP-dev workshop. That took a while, took multiple years. A lot of things may have gotten slightly worse in the meantime. It took maybe some years to provide the features that we said we were going to provide. We got through that. We got through that trough. 2023, my evaluation was that we are proceeding from kind of an active period of development into a plateau of productivity, and I think that evaluation is accurate. And now I'd say we're steadily in the plateau. People just use JuMP. We're not like rewriting things anymore. It's a rather mature piece of software, and a lot of the activity is happening on the periphery and in the ecosystem of JuMP rather than in JuMP itself. So that's exactly what I just said. JuMP's stable and relatively mature, and you're going to see more activity around in the ecosystem than in JuMP itself. Okay, so to give some data to support that cartoon, this is a count of the open issues over time. The green is open GitHub issues over time. The green is corresponds to the JuMP repository, and the orange corresponds to the MathOpt interface repository, which is the backend, the new backend for JuMP. And you can see the decision to rewrite everything happened around 2017, and then the collection of issues kept piling up for quite some time, and it took until the end or beginning of 2022 to get through that rewrite process and come out on the other side with a very solid and mature piece of software. And since then, issue counts are pretty stable. I'd say like maintenance is in a good state right now, which is good. At the same time, we can look at the number of academic citations per JuMP. JuMP has had 3 kind of core publications that we've asked people to cite over time. The first was titled Computing in Operations Research Using Julia. Second was about JuMP itself, and the third was a technical note about the release of JuMP 1.0. So here I'm just tracking the number of citations per year, and we're in a pretty steady and gradual increase per year, and this gives an indication of even while JuMP has been stabilizing, we're kind of steadily increasing the number of citations, so that's a good sign for the adoption of JuMP. Okay, so in the past year, what happened since the last JuMP-dev workshop? We've released, gone from version 1.22 to 1.29. We released there's been some new extensions. New GPU-enabled solvers have become available through JuMP. This has gotten some excitement in the broader optimization community. And the point that's most directly affected my life, we've had the 2 additional babies born to the core development team. Which brings me to a kind of a concern I have. If you look at the timeline, there was 1 baby born that I talked about in the 2023 workshop, another one in 2024, and there's been 2 at in this workshop. So there's like a very well-known numerical sequence that starts 1, 1, 2. So I'm a little concerned about what's going to happen next year, but we'll see. Okay, in terms of new extensions or more abstract layers, we have MathOpt AI, MathOpt Analyzer, MathOpt Chordal Decomposition, MathOpt IIS. I'm highlighting the ones where the JuMP core developers have had a role. I know there's even more out there. I'm not trying not to pick the winners and losers, but I just wanted to highlight the activity that's been going on, and we'll hear more about some of these extensions at the workshop. Getting into the actual technical things that have changed in JuMP, there's like fewer things to report in JuMP than let's say last year. One thing that's interesting and useful is macro profiling. It allows you to set a flag and report the amount of time spent in the JuMP macros, which we've determined was, or figured out is useful for developers or authors of rather large models where it's hard. It is possible where you might write a constraint in a certain way or write an expression in a certain way that's not efficient, and this profiling tool helps you figure out where the bottlenecks in your model generation are. Assert is solved and feasible. Actually, I do prefer long function names, thanks to my experience at Google and the Google style guide. So this function does what hopefully its name suggests. It adds an assertion in your code that the problem has been solved and has returned a feasible solution. And this is kind of a convenience for maybe quick scripts where you don't care if the solver didn't work, you just want to crash. Otherwise, you want to check that you have a solution. This is a useful tool. If you're writing more involved code, hopefully production code, you do want to be more robust to all the different things that can happen when the solver does not return successfully. We have a fair number of new or revamped tutorials in the past year. I'll just list them: fitting of circles and ellipses, finding multiple feasible solutions, tolerances and numerical issues, Bender's decomposition, how to write a solver interface, how to solve rolling horizon problems, and how to think about the performance of formulations that have like conditionals inside of sums. So there's a fair amount of content. All of these take a lot of effort, and a lot of these have been contributed by members of the community. So thanks to everyone who's helped improve our documentation. And like these are very important documentation that we provide to users, and now probably ChatGPT has now consumed all these. So if you ask how do you write your model more efficiently, um, maybe you're actually not literally reading these tutorials, but someone or something has read these tutorials for you. Other points that are worth mentioning, we have a symbolic AD backend that was previously experimental, that has been merged into MathOpt interface. The LP file reader was rewritten, hopefully for the last time. We'll see. Yeah, so the OR community has a legacy of many file formats, some of which were designed for punch cards, and LP format is not one of those, but just reading and writing optimization problems into files is a surprisingly complicated endeavor. Vector nonlinear oracle is a component that mostly useful for extensions, so I won't go into the details there. Solvers are allowed to return multiple conflicts now, which is related to one of the extensions under development and useful for analyzing what might happen, understanding what might cause a model to be determined as infeasible. Automated installation, that rollout has continued to include the Express and Nitro wrappers. This is one of the things that hopefully users never need to think about. It just works. And although prior to that, it does solve a lot of installation problems that previously you had to worry about how to download and set up the software. Now it just works. Good. Improved test coverage, that was a big push over the past year. And that's all I want to cover. So in addition to just like the providing a software package that people use and build things on top of, I also do want to talk about JuMP's influence in the community. So I previously mentioned that JuMP has, previously in a prior talk, that JuMP has inspired modeling packages outside of Julia. So on the C++ Python side, this includes the MathOpt library that's part of the Google OR Tools package. In Python, there's a software package called PyOpt interface. In R, there's OMPR, and these are all packages that have been influenced by JuMP, and I think that's a great thing. Examodels is not directly used in JuMP, but this is a package that has really benefited from using Julia, and they were recognized with the 2023 Cornell Cup, and they previously gave a talk at JuMP-dev that really follows with the high performance and high performance functionality of Julia, and I think JuMP was that was one of the original pushes of JuMP, like look what we can do in Julia, and I'm glad to see that the community has taken that message and used Julia for other successful optimization projects. We have GPU-enabled solvers in Julia. A lot of these were developed in Julia, so MadNLP, Clarabelle, cuPDLP, and related software. So these kind of new state-of-the-art solvers, Julia was used or is used to do that research and provide state-of-the-art solving. So that's really cool. In addition, SCS started adopting new cones, which follows with our convention in MathOpt interface. If you've gone down that rabbit hole, you know that we support a lot of different ways of modeling conic sets, and originally we introduced cones that did not really exist in solvers, and now solvers have started providing backends to take these cones. So this is showing how JuMP is basically influencing solver development and influencing how the broader optimization community thinks and approaches these problems. So that's all, I think, an important aspect of JuMP in addition to providing a software package that people use. So what's next? Next is we hear some great talks, and we're here, especially the JuMP developers, to listen, learn, and discuss how to make JuMP better. So thanks, everyone.